how to implement all the basic concept of stats using Python. And this is the second part of my video. If you have not watched my first video, which I was talking about the basic concept of all the descriptive stats, for example, you can see here mean, median, mode. So already I have given the basic concept. Okay, so in this video I'm going to talk about how to implement this all concept using Python, because Python is a important language in terms of machine learning, AI, artificial intelligence, right? So in this video, I will give one use case of one data, and I will load the data, and I will do a EDA kind of activity, and I will demonstrate you that important concept of a stats using Python, and you will find that how to analyze the data. What are the basic methods of function of Python and the basic concept of stats, and with the help of that you can do EDA kind of activity, or you can analyze the data. Okay, so let's get started. And this video is for those people who really want to become data scientist, a machine learning developer, you want to become in that field. Okay, so let's get started and let's understand how to perform some basic operation of stats using Python. So let's get started. As you can see here, these are the basic concept of stats, like central tendency, like dispersion, like symmetry. These are all things I have already talked about in the previous video. Okay, so this is all our basic concept, and let us say using Python. So what are the different library of Python you can use to calculate this all data? Okay, so here I have already I'm using Colab, Google Colab. Okay, and I have important couple of library here. For example, SciPy is library for a stats operation. NumPy is it's a Python module where you can deal with data like matrices, like arrays. Okay, and plotting, I'm also using some plotting kind of thing to just demonstrate the how the data look like using matplotlib, pyplot I'm using. Okay, and Seaborn, I'm using Seaborn here. Seaborn is also good library to, it works along with pyplot. It works on the top of pyplot, where you can draw very good or advanced kind of diagram or graph kind of things. Okay, so these are the library here in order to work with the stats. And the important library is the NumPy, because the mean, median, mode, these all things you don't have to calculate manually. If you know the formula, it's okay, but you don't have to calculate manually. All the operation, all the functions are written already in the NumPy. Okay, so these are the library I'm going to use that. So let us understand some data first of all. Okay, so I'm going to walk through this whole thing one by one. Okay, so first thing, I want to get some data. Suppose I want to perform some kind of operation, I need some data, right? So for getting the data, what I'm doing here, Seaborn. Okay, Seaborn is a module. So Seaborn has already a lot of data. Okay, if you really want to see all the data which are available, which are present under Seaborn, then you can use this method of Seaborn. I'm just renaming it as a SNS. Okay, so SNS dot get dataset names. Okay, if you run this, let me run this. So I'm just calling this function get dataset dot underscore names. It will give you all the data sets which are present under Seaborn module. You can see that. So these are multiple data sets, and these all data sets you can use for kind of learning or kind of implementing of machine learning model. So it has bunch of data. Okay, so in this video I'm using this data, taxi data, this data to just for a couple of just to demonstrate couple of concepts. Okay, so for time being I'm just going to comment this out because it takes a lot of space. Okay, so now here, so from this function it will give all the data set name which are available. Now the next part, I'm going to load my data set. Okay, I want to load the taxi data. So this is the function you have to use of SNS dot, I mean Seaborn, from Seaborn dot load data set, and give the data set name, and it will load the data. Okay, so here I'm just loading, I'm just giving a variable name like taxi underscore data, and then it's a panda. Okay, it's a series. Panda I will cover later. So you can see that I want to see the data, that what are the data available. Okay, so there's a head function of Panda series where you can see first top 5 data. So it will display you top 5 data. Okay, so I'm not doing a complete analysis or complete ED here. My purpose is to demonstrate you the basic concept of a stat using Python. Okay, so I load the data, and here from this data I want to pull totals. You can see that it has a lot of, it's a taxi fares. Okay, how much fares was paid, it has in dollar. These are the total fare. So here my purpose of this video is that on this attribute total, whatever data it has, okay, I want to perform a descriptive statics. I mean, I want to understand how the data, this total are, I mean, how this data uh, are are in this data set. Okay, how this total fare are constructed, or what are their distribution, what are their mean. I mean, I just want to examine all the total, okay, inside the data set, that how they are looking like. And for that I'm using this tool called stats. Okay, so how to do that? So here I load the data. Okay, now next part, I want to load only specific data, which is total. Okay, which I want, this is my interest. I want to perform some analysis on the test. So for that, from the taxi data, so the taxi data is a series. Okay, from this taxi data I want to load only total, this column, right? So here this is the operation taxi data, and I'm passing the column name. Okay, so this will fetch me all the total fare. Okay, so if you run this, let me run this. So you can see that it is giving me all the totals, this total fare starting from $12.95. Okay, so you can see that there are around, it has how many rows? 6,433 rows. Okay, so these are the, it have more than 6,000 record of fare which I got it right. Now I, as a data scientist, suppose I got this total fare, right? I just want to understand from the data science perspective, this data are how they are spread. I mean, how they are scattered, what what are the property inside the data, what are the outliers, okay, how they are constructed within the data set. I mean, I just want to examine this data. That is my purpose. Okay, so I want to do some kind of mathematical analysis on this numerical data. So how to do that? So that's why stats come into picture. That's what we're going to see that. Okay. So what I can do with this numerical data, these are the operation I can do. I can understand what is the average, what is the median, what is the mode, what is the standard deviation, what is the range, what is the IQR, what is the Z score, and how the data are scattered, what is the symmetricity, skewness. Okay, this all thing I have already covered in my previous video. So this all thing, let us examine this a whole bunch of concept using the Python. Okay, so I got my total fare. Okay, this is my area of interest where I want to perform some kind of analysis in this video. So let's get started. Okay, so first thing is the mean. Okay, so how to find the mean? One thing I want to add here, NumPy, the Python has a NumPy library which having all the functions which are required to perform descriptive stats like mean, median, mode, everything, almost everything it has. Okay, so I'm using NumPy along with SciPy because SciPy has some additional functions. So these two modules is important if you really want to perform kind of descriptive stats. These two modules are very important. Okay, so now let's get a start. So first is the mean, how to find the mean. So I got my total fare. This is my whole bunch of data. So from this whole bunch of data, I want to find the mean. So very simple. Okay, NumPy has already all the functions are there. So I'm using numpy.mean. Mean is a function under NumPy. You just use mean and pass the data where you find you want to find the average. So it will give you mean data. So I'm just giving a variable name like fare underscore mean. I'm just printing it. Okay, if I run this cell, it will giving me that 18.51. This is the average fare. Okay, out of this total fare, what is the average fare? It is 18.51. So I got some insight from this data. Then I want to find the median. middle part. Okay, I hope this all concept I have already covered mathematically. I'm not going to talk about that. I'm just going to give the Python side. Okay, so I'm using np.median. Okay, and just pass the all the data. It will give the median. Okay, so this is the middle point. So what is the middle point? If you arrange, if you, let's suppose this data, okay, if you arrange the data in the ascending order, what will be the middle point? So the middle point will be 14.16. Okay, this is the middle point of the pair. Then I want to find the mode. What is mode? Is a frequency. Okay, which data point is mostly occurring the most number of times. This is the called mode. Okay, so how to find the mode? One thing, np numpy has no any function as such to find the mode. Okay, so that is why I'm using this scipy. Okay, so scipy has one function called mode. So I'm using scipy stats module. Okay, stats is one of the module where you can perform all the statics or advanced kind of a statics kind of operation. So I'm using a speed.stats.mode. I'm calling the mode function. I'm passing the fare, which is my interested data, and it will give you all the mode. Okay, I'm just printing it. So it is giving me this result that mode is equal to 9.3. Okay, so 9.3 is a data point in my data set which is repeating the most time. And how many times it is repeating? 146 times. So this is the mode, right? Now, next I want to find the mean, which is very simple. What is the minimum fare? Okay, you can use np.min. Okay, this is a very simple, cool, easy function. Okay, np.min, pass the total fare. It will give you the mean fare. Okay. You might be thinking why I'm finding this all data point, like why I'm finding mean, what I'm finding average. This I will summarize by end of the video. I will conclude everything. Okay, why this all data point, this all observation is important. I will conclude that. Then I'm finding the max value. What is the maximum fare? Okay, so we have np has a max function. Just type pass the value and it will give the max function. Very simple. And next is a standard deviation. I hope you understand what is standard deviation. If you have no idea about it, it's a mathematical term. If you don't know about what is standard deviation, I have already created a video on this topic. You watch my previous video. Okay, you will find the link in the description box of our first video. So here np, again I'm using numpy. Numpy has a standard deviation function. Okay, I'm just passing them my total data which I want to find the standard deviation, and it will give you standard deviation. Okay, so this is my standard deviation. So this talks about the spread, how the data are spread in within your data set. Okay, so I got maximum, all the data point I got mean, I got median, I got mod, I got standard deviation. Okay, I got range also, I got the mean point, I got the max point. Okay, so here as of now I'm using individual function one by one. First I use mean, then median, then stat. I'm using one by one calculation, mean and max. Okay, but basically you don't have to do that. Okay, so np has a very good function called percentile. Okay, and this percentile, whatever I did the calculation, like mean, max, median, mean, okay, average, this function will give you all the summary. It is called 5-number summary. Okay, what is 5-number summary? I have covered in that video. Okay, so you can use this function percentile. Okay, from numpy, it comes from numpy. You have to pass the data from which data you want to investigate. Okay, and here, okay, what is the percentile? Uh, so I want to understand by the way, this I have already covered in my previous video. Okay, so here I'm passing that what is my quartile, the first quartile. I mean the quartile divide the whole data point into 4 parts, right? 25 25 in the 25% of chunk. Okay, so that's what I'm passing here. Okay, first is 0, then 25, then 50, then 75, then 100. So this is my data. I want to get the percentile. I hope you understand that. If you're not finding this, if you have confusion in that, I have covered in the first video. Okay, and then I want to find the midpoint. If you pass this is a very useful function. You can make a note of percentile. It will give you the complete summary of your data point. Okay, it's very handy. So you can see here, if you run this, it will give me this kind of result. Okay, so let me explain this result, what it is doing behind the scene. Okay, so the first point you can see here, 1.3, it is the minimum data point. I mean it's the minimum fare. Okay, you can see that I have already find the mean, right? using np.mean, which is coming about 1.3. Same result I'm getting from percentile also. Okay, same result. Okay, in just one line. So I'm getting the mean is 1.3. Okay, and the last point is the 174.82, which is the max value. I have already calculated the max, which is coming 174. Okay, so here it is in the same value. So this summary is giving you what is the mean point, I mean what is the minimum fare and what is the maximum fare. Okay, so this become your range, right? If you subtract between max to mean, it will give the range. Okay, so it is giving you a picture. Why this all data point is important? It is giving you insight about your data, that my fare on in this data set are between this range. So minimum fare has been paid $1.3 and the maximum fare has been paid $174.82. It's giving you a range. Okay, so your whole data set are within this range. You got one insight about the data, where what is the range of my data, from where to where it is scattered, right? So I got the range. Okay, after that, the middle point. Okay, this middle point. Okay, so this, the first point is the mean point, this is the max point, and the middle point is called median. Okay, it is a median fare. If you find the median, I have already calculated using np function median, it is coming around 14.16, right? Same, exactly same value getting here, 14.16, using percentile function, right? So I got three insight. First insight is, this is my mean data, this is my max data. I got the whole range, that my fare is between 1.3 to 1.74.82. I got one range. And what is the middle point? Because median talks about the middle point, right? If you know that. So the middle fare is a 14.6. This is the midpoint. Okay, you can say it is not average. Average is a different thing. Okay, it's a median point. Okay, and yeah, and this second point, okay, it is called Q1, first quartile. Okay, and this fourth one, this point is the Q1 and this is the Q3. Okay, I hope you know what is the first quartile, what is the second quartile, what is the third quartile, what is the IQR. This whole concept I have already covered in my previous video. If you have not watched it, I will recommend watch, and you will find the link in the description box. I have already covered this whole concept. Okay, so I'm not going to cover again. I'm just going to show the description about it. Okay, so this is my QR, first quartile, this is my Q3, this is my middle point. Okay, and if you subtract Q3 minus Q1, I mean 20.3 minus 10.8, it will come out what? IQR. It is called interquartile range. Okay, so you can see here, this function is very handy. It's very important function, very useful function. It will give you the whole bunch insight, complete insight of your numerical data using single function, percentile. What is my mean? What is my max? I got the range, I got the middle point, I got the median. What is my first quartile? What is my third quartile? What is my range of the quartile? It is giving you a whole bunch of ideas, right? So from this, as a data scientist, you will get the insight, right? Why I'm doing this all thing? To just find the insight of my data, that how my data are scattered, or how they are within, how they have been scattered within the data range. That's what the purpose. Okay, and now let me, so whatever I have calculated here, everything I'm summarized in just one cell. So what is my mean, what is my median, what is my mode? You can see that it is giving the complete summary of the data. Let me run this, and from here you can, as a data scientist, you can find some insight, some calculation. You can understand the data pretty well, that how my data is looking like inside my data set. Okay, so you can find that what is my mean, this is my average fare. Okay, so out of uh, 1.3 is my the lowest fare, I mean the lowest money has been paid, and 174.82 is my max fare. Okay, and what is my average fare is 18.5. So most of the people, okay, have paid $18.51 as a taxi fare, most of the people, which is my median. Okay, which is my mean. Okay, and what is my median? 14.6. So 14.16 is my median, and 18.51 is my mean. Okay, If you have a confusion between what is median, what is mean, it's both are different thing. I have already covered in my previous video. Again, I'm suggesting go and watch the video. Okay, so here there is one calculation. Okay, this is very important point I'm going to share with you. You can see that your median, okay, which is 14.16, and mean, which is 18.51, it is not exactly same, right? Your median and mode, let me make a point here. What I'm trying to say here, your median is not equal to mean. This is what I got the observation from the data point, right? So my median is 14.16. Okay, let me make a note. So my median is 14.16, right? And my mode, my mean is how much? 18.51. Okay, I got this two data set. Okay, so now my friend, from these two data set, only from this two data set, it will give you the complete picture or complete insight of your data. If you're experienced data scientist, then you will find out that from these two data, from these two feature, okay, what I can conclude, what is my conclusion here? If you understand median and mode, okay, so I can conclude from this two data point that it is my fair has no normal distribution. Okay, fair has no normal distribution. If you understand the logic, okay, what is median, what is median, and what is mean, if you understand the logic, so this data set is saying that, okay, that there are some outliers. I mean, it is not a normal distribution. By the way, what is normal distribution, I will talk about in the next video. I will create a complete video on that topic. Okay, but from this data set, I find that, okay, generally the median, okay, let me, if I draw a line, okay, okay, let me, one second, let me explain this way, what I'm going to talk about. So how it is giving a lot of bunch of idea, okay, one second, let me draw this line, then I will give the idea. Okay, so let's suppose this is my one line, okay, and this is my mean. Okay, let's suppose this is my mean. Okay, okay, mean is what? How much mean is that? 18.51, median is 14. Okay, mean, let's suppose it is 18.51. This is my mean, right? And where is the median? 14 point something, right? What was the median? 14.16. Okay, this is my median, right? 14.16. Okay, so you can see, because 14.16 will come before 18.15 if you draw on the line, right? So because 18.5 is more than, this is more than, sorry, yeah, this is more than. So here my mean, what I'm finding observation here, that my mean is more than median, right? This is what I got the observation from the data set, from the data point. This is what I got, right? So it means that if it is the case, if your mean is not exactly, or it is not equal to median, it means that there are some outliers. Okay, and your data points will be not normally, I mean, there will be some skewness. Okay, if you really want to find the uh, distribution of this data, so this distribution will be look like this. Okay, suppose this is my mean. Okay, so so mean is more than median. It means that this data point has some skewness. I mean, it has some outliers. Okay, it has some extreme points. I will prove that right now. Okay, but here, only from these 2 points, only from the median and mean and median, if you know the logic, you will have the insight that my data set has some outliers. I need to work on outliers. Okay, again, it depends upon the business requirement whether you really want to remove the outlier or not. This completely the business logic, business call. Okay, but from as a data scientist, I came to know they have some outlier because my mean is not coinciding with the median. Okay, this is one observation. Okay, this is what I found, right? So this I mean this number summary is very handy, very important function. It gives you complete, if you understand how the data is there, you'll find a complete idea about the data set. Okay, so here I found some. Now as of now, as a data scientist, I'm able to visualize my data, that how my data is scattered in the data set. It has what is the mean, what is the maximum, what is the average, what is the median. If mean and median is not coinciding, they are not exactly equal, it shows that it has some outliers. It can be either right skewed or it can be left skewed. It is not completely normal distributed. There are some skewness in the data set. I got this all idea, I got only from this point, right? If I had this summary, i will I will get the complete insight of my data. I hope you got it right. Now, next point I want to talk about Z score. Okay, what is Z score? I have already covered in my previous video. If you have not watched it, this is a very important concept. Please go and watch. You will find the description box, the link in the description box. It is a very important concept, and Z score is widely used in stats in machine learning. Okay, it's a very basic foundation. Okay, so how to find the Z score? I'm not going to cover the very detail because I've already covered in the previous video. Okay, so Z score, how to find the Z score of any point? Let's suppose I have how many? I have 64. How many? 6,400 data set, right? So you can find the Z score of every data point. Okay, if you plot a graph of this data point, there will be multiple, there will be continuous data, right? There will be multiple, like 64,000 data point, right? You can find the Z score of every data point. Okay, so Z score gives you idea that how I mean it gives the idea of scatter, I mean your what is called how the data are scattered. Okay, what is the deviation, or what is the you can say standard deviation. Okay, how the data are I mean from the mean. Okay, suppose you have average point from the mean, how the data are uh, scattered around the median. I have already covered in the video. Okay, so how to find the Z score? Again, it's a basic, it's a very simple formula. I've already covered there. Okay, so this is a formula. You just give the data point for which data point you want to find the median. Okay, for example, let's suppose Q3. I got this Q3, right? So I want to find I at randomly. Okay, you can find the Z score of all the point, but here for demo purpose, I'm selecting this point 20.3, which is my Q3. Okay, I'm interested to find what is the Z score of this data point. Okay, so how to find that? It's very simple. This is the formula that you have to give the x, what is the data point you want to find, minus your mean, divide by standard deviation. This is a formula. This is the mathematical formula for finding the Z score. Well, I have already covered in that video. Okay, so I'm just passing my data point, which is 20.3. What is the mean? Mean I have already calculated, and what is my standard deviation? If you calculate this, it will give you this point. Okay, so why it is important, Z score? Let me explain that. So Z score is used to find the outliers, right? You can see that from this here. Okay, if I found that my mean is more than median. It means that there are some skewness. I mean, your data has some outliers. From this statement, from these two data, I got to know that. Okay, but here exactly I want to find the exactly all the outliers. How many outliers are there, and which data points are outliers? I exactly now to find that. Okay, so in order to find that, you can use Z score method. Okay, so there's a principle. Okay, this principle I will talk about in the next video when we cover about normal distribution. Okay, but for right now, just memorize that if any point, okay, if Z score, this is the concept. If Z score is more than 3, okay, in the positive side, or Z score is less than -3 in the negative side. Okay, so if it is the case, then all the data point which having the Z score more than 3 or less than -3, those data points are considered to be outlier in your data set. Okay, how to establish this concept, this principle. For that, you need to understand the normal distribution, which I will cover in the next video. Okay, so here, my friend, I have written very small function, simple logic in using Python. Okay, so here I want to calculate what I'm doing here. I have a total fare, right? This is my whole data point, which is more than 60,000, right? 6,000, right? So in this data set, I want to investigate how many points are outliers. This is what I want to achieve here using this concept. Okay. So what I'm doing here, I'm just creating a loop. I'm just iterating the entire my data point. Okay, and for each data point, let's suppose x, it is my each data point. So for each data point, I'm trying to find the z score. Okay, so this is the formula to find the z score. I hope you know that, right? So x, the data point which you got it, minus mean divided by standard deviation, which I have already got. Okay, so this line, this statement will give you what? Z score of point x. It can be multiple x, right? There are multiple points within the data total fare. So every fare, I'm finding my z score. Okay, now let's suppose I got the z score. Here I'm doing one comparison, because this is my principle, right? If my z score is within this range or not. Okay, so here whatever z score I got it, I'm just doing one if loop, if condition, conditional statement. I'm putting one condition: if z score is more than 3 or z score is less than -3. If this condition is satisfied along with this with respect to this z score value, it means this data point x, right, it is an outlier. If this condition is satisfied, it means that x is an outlier. It's very simple principle, right? So here I'm creating a dictionary. Okay, I'm just finding okay, I found that this is my outlier data. So I'm just creating a dictionary. The key is the data. Okay, and the value is the data score. Okay, and here I have an outlier list. Okay, so this dictionary I'm just appending into my list. So this logic will give me all the outlier data point which are in my fares, total fare. Okay, if you run this, I'm just counting the length. Okay, whatever I got in the outlier, I found that there are 185 fares out of 6,400 fares are outliers. These are the points which are having the outliers. Okay, I exactly want to know which data points are outliers. How to can do that? You can I can write another statement here. Okay, and you just pass the list here. Okay, let me remove the length function, and I want to know the exact data point. Outliers data points. I want to know exactly which data points are outliers, right? Let me run this. Okay, so they are total 185 length. Okay, you can see that 100.38. Okay, this is the one data point. Its z score is 5.9, which is more than 3. I mean, it is an outlier, right? 65.56. You can see here it is giving all the data. This is the x, this is the key, which is my actual data point, and the value is the z score. I'm just creating a key value pair. What is my x value and what is the corresponding z score? Okay, so you will find that this whole data set, the z score will be more than 3, either more than 3 or less than -3. Okay, it is giving a bunch of idea. So this way, my friend, it will find the outliers using, it's a very good process using z score. You can find the outliers. Okay, so this way you can have the idea. So now I got that. Okay, I have already find that I got the insight that in my data point it has some outliers. Okay, now how to, as of now I have not used any graph or I have not used any visualization. I'm just only from the data point. Okay, only just from only from this summary data point I got the idea. What is my range? What is this? Oh, I got bunch of idea, right? I got that. I found that it has some outliers. Okay, now I really want to visualize it. Okay, so for the visualization purpose, you can use PyPlot or Seaborn. These are the visualization library in Python you can use for visualization purpose, which I'm using right now. Okay, so here once I found that it has an outlier. Okay, now there's one concept of skewness. Okay, this also, so as my first iteration, I know that it has outliers, right? Now I want to further strengthen my concept that is it I mean, I really want to again I just want to confirm. Okay, so for that, it's a concept called symmetricity. Okay, if your data set, let me explain that what is the symmetricity I'm talking about. So if it, well, I will cover in new video about this concept. Okay, it's very important concept, but let me discuss about that. Okay, so see, if you understand the what is the normal distribution, so there are three kinds of graph. Okay, suppose this is my mean point. Okay, if you draw this graph like this, okay, and if you plot a line here like this is one point. Okay, let me draw that. Okay, and yeah, this is one, and this is like this. Suppose this is my here mean. Okay, and this point is like this. Okay, and another is like this. Okay, and it has something like this. Okay, so you can see that this graph, it is called symmetric graph, because if you see that, if you this is the new point. Okay, both side, okay, it's symmetric. If in the geometry, if you know that what is the equivalence or symmetricity. Okay, if you, I mean, if you cut, let's suppose if I cut this graph from the middle point. Okay, we'll find two parts, this part, right, and this part. So both part are exactly symmetric. It is called symmetric graph. Okay, and it is called normal distribution. It is called normal distribution graph. Okay, but there's some variance of it. Okay, let's suppose this graph. Okay, so this graph is also, you can see that this is also a normal distribution, but not 100% symmetric. It has some skewness. Okay, so because you can see that it is called tail. So in the right side, this graph are a little bit stretch. Okay, in the right side, it is a little bit stretch. It means that it has some outlier. This data point, because of that, it here what happens in this case, in in this case, your mean and median will be exactly at same point, almost same point. Okay, in this case, in the right skewness, your mean will be, okay, let me put a point here. Okay, so your mean, this is your mean. Okay, and here it will be the standard deviation. So in this case, what will happen, your mean will be shifted toward right, because it has more data, heavy data point. These are the outliers, right? It has more heavy data point. So because of this heaviness, your mean will be shifted towards, to just adjust those data points, your mean will be shifted towards right side. And because of that, it will create a skewness kind of graph. Because of that, because your mean is a little bit shifted. Okay, it is not 100% symmetric. If you suppose this is my mean, okay, so your graph not will be symmetric. There will be some, I mean, not exactly equal the both side. Okay, exactly here like this. So the skewness can be the both side. It can be the right side, it can be the left side. Okay, in the, because the outliers can be both side, either positive side or negative side. Okay, so let's suppose, I'm giving example. Let's suppose you have a salary data point. Okay, in the salary data point, most of the people have an average salary, but in the data point, there could be a couple of people who are industrialist, who are business person, who have a lot of money, who have huge money, like actor, actress, right? So those data point are like a huge numbers, a huge salary. So it is a skewness. Data will be a skewness. Okay. At the same time, there will be a lot of poor people whose salary is below the standard, below the average. So their salary will be very low, and because of that, there will be skewness on the left side. Okay, and in this case, your mean will be shifted towards here. Okay, your mean will be shifted towards left side, and median will be here like this. Okay, so whenever there is a median and mode, if they are not exactly at the same point, it shows that it has some skewness, either left side or right side. Okay, and it has some outliers. So, and next is what you want to do with the outliers, it's your call. Okay, but I found that it has some outliers. Okay, so how to find the skewness? Okay, I just want to, from the data point, I just want to know whether my data points are, the graph are like this or like this. I mean, it has some skewness or it has no skewness. I hope you got the point, right? So for that, uh, SciPy has a function called skew. Okay, I'm using here sp.stats dot skew. Okay, and I'm passing my total fare, which is my data point, and it will give you a skewness. Okay, so so there's a principle here, skewness. What it talks about, if your skewness is within this range, okay, if it is within the -5 to 5, it's a stats principle. Okay, if it is between minus zero point 0.5 to 0.5, okay, it is said that it is almost normal distribution. I mean, there is no much skewness. Okay, but if it is more than, okay, if it is more than 1 or less than 1 minus 1, then it has more skewness, either left side or right side. Okay, so this is the principle. So here I'm trying to find the skewness for my data point. What are the skewness value? Okay, so I'm using a stats function of sp size pi. Okay, I found that for this data set, my skewness is coming about 3.09, which is more than 1, right? I mean, it has skewness. If it is more than 1, then it is shows that it has some skewness, and it is more its skewness at the right side. Okay, I mean, right side means it has more fare, heavy fares. I got the idea, right? Now, I really want to see graphically. I want to visualize it. Okay, so in order to visualize your outliers, you want to really detect the outliers. The best part is the box plot. Okay, I'm using box plot. Okay, so if you, let's suppose I'm using sns.box plot. If you draw this graph like this, okay, it will create a graph like this. Okay, you can see here it has couple of points which are very far away. So these are my outliers. So graphically, first I calculated, first I did all the analysis. I got all the insight from the numerically, like mean, median, data point, data score, and percentile. I got whole the idea, right? Now I just want to confirm my idea. Whatever observation I calculated, I just I just really want to confirm with the graphically. So that is why I'm just confirming my idea. Okay, so that is why the best is the box plot. It will give you the box plot is very it gives you a whole 5 summary data point. Okay, uh, I can create another video for box plot. Okay, so this is the idea that it has some outliers. Okay, so it is this called mean point. This is the max point. It has the median point. Okay, and this box, this box, the width of the box is the IQR, interquartile range. Okay, so this is the Q1, this is the Q3. Okay, and another is the hist plot. If you really want to see the graphical representation, this is a very good plot, historical histogram or hist plot. Okay, so can see that I'm just plotting his plot. I'm just passing the total fare. Okay, and so graphically how the data are distributed, I got this idea like this. You can see that. So it is showing whatever I establish my analysis that it has some outliers using Z score, right? I did a calculation that it has some outliers, okay, and it has some skewness. So skewness is more than 3. Is how much is coming? 3, right? So from this data point, if I combine this data point, I got a conclusion that it has some skewness at the right side, and this is what histoplot will give you the exact idea. So whatever I did calculation, my observation, I'm trying to convince myself, or I'm trying to prove myself, yeah, that is the right thing. Okay, so that is why it is not 100% symmetrical. You can see that it has some in the right side, it has skewed. Okay, it is stretched. It is called tail. Because of that, it has outlier. It has some heavy fare, and because of that, it has been shifted. Okay, so I got my analysis. Okay, so now I just want to compare here. So it is giving me idea that it is not 100% symmetrical. It is not 100% symmetric, right? Because of outlier data point, right? Here, for sake of normal distribution, I just want to compare. Okay, here I'm giving one example that how the normal distribution chart look like. Okay, so here, for example, I'm taking some random data. I'm using np.random.normal. So I'm trying to get the normal distribution data point from 1 to 3000. Okay, I'm using this one, and I'm trying to plot this. Okay, you can see that the difference between this graph and this graph, in this graph, you will not find much skewness. It is almost symmetrical, right? So this data point is symmetric, but this data point is not symmetric, right? So here, from this idea, let me summarize that. Okay, what I did. Okay, so for the given data point, for example, total fare, I just let's suppose I found that this is my important feature. Okay, I want to build a model, and I found that this is very important feature. So I just want to do some analysis, and it's a numerical kind of data point, right? I want to perform some analysis, like what is the mean, whatever the basic stats are there, like mean, median, mode, standard deviation, range, IQR, Z score, skewness. These are the descriptive stats. I want to perform all the descriptive stats on my given data point. This is what I did. Okay, and I got a conclusion that it has what is the mean, what is the max, and I found that median and mode are not exactly coinciding. It shows that mean, you can see that mean is more, mean value, mean is how much? 18.51. And what is the median? 14. So here mean is more than median, right? If mean is more than median, it is right squared. You can see the graph also, right? Like this, because here the mean is more than median. Okay, so this all analysis I'm doing, and then I found that okay, it has some skewness. Okay, I found that it is not normal distributed, it is not symmetrical, it has some skewness. I found this outlier, and I want to find all the outliers, which are the data point is the outliers. I got this whole idea, and graphically I want to present that. Okay, so this way you are doing the very basic or EDA or very basic analysis on your data point. Okay, afterwards, what is the next step? Next step is that as of now, you know that your data point are not 100% normal. It has some skewness, it has some outliers. Okay, now you have to take a decision whether what you want to do. You really want to keep these outliers depending upon your client or depending upon the business need. Okay, or you really want to remove it, or you want to replace this outlier with some data point, maybe mean or median or whatever. Okay, there could be multiple thought depending upon the business need. But here, from this basic analysis, I got the whole idea about my data point, how the data points are looking like, how they were scattered, what is the range, what is the deviation, what is the skewness, their distribution. I got whole bunch of idea from this logic. Okay, so this all logic we perform on the numerical data. Okay, so this is all in this video. I hope you got the entire idea about stats, how to implement basic function using Python, and what are the basic steps required to perform analysis on the numerical data with this all function. I hope this video was useful, and if you really want to learn more, you can reach out to us. Okay, in the next video I will talk about very important concept about the normal distribution. Okay, which is very important. Okay, this is all in this video. I hope you found a lot of value. Keep watching. I will come back with a more video. Till then, goodbye, take care, bye.